You should not be exposing your API servers if they are sitting behind a load balancer. This defeats the point or the purpose of a load balancer. So this diagram right here consists of a load balancer, could be Nginx, and a lot of application servers, which could be individual node servers. And then we have our clients connecting and getting back the resources. And load balancers are helpful for sites that receive a lot of traffic and requests. For example, a ton of requests might be too much for a single server to handle. To handle this, multiple servers can be deployed. These servers often host the same content, and the load balancer distributes the requests among the servers in a way that optimally uses each server. This prevents the servers from overloading and makes maximum use of each server's capacity. The key here, though, is that load balancers distribute the requests among the API servers. The clients are not contacting the API servers directly. In other words, any contact with the API servers should be coming from the load balancer directly. And to ensure this is the case, the API servers should not be exposed over the network. So in this example here, we have our load balancer. Notice how all the clients are speaking to the load balancer, which then talks to the application servers and then returns the content. If the clients were talking directly to each of the application servers, or just had the ability to, that would kind of defeat the point of using a load balancer. So let's do a demonstration now. So consider this Nginx configuration right here. This configuration essentially creates a group of node servers, which are all accessible on the same port. So this is our upstream. Each one of these servers, it's inside a Docker network, and this is the port, and this is the domain. The domain can be something like this because Docker will perform DNS under the hood in the Docker network. But essentially what happens here is any request to API, Nginx will proxy all the requests to this backend cluster, where these servers will then handle it in a round-robin fashion, with extra weight placed on server 1. And as this is in a Docker network, let me show you the Docker compose file. And the most relevant point of this file is the ports. So notice here, we are mapping an Nginx port on our host machine to an Nginx port in the container. But these up here are our node servers with 6 replicas, and we don't map any kind of ports. We can see this more so if we run docker ps. These right here are all our node servers where they have no port mappings. And this right here is our Nginx server, which accepts all the requests and then forwards it among these servers. So we can't contact these node servers directly. If we actually wanted to access one of these node servers, we would have to be inside the Docker network, which let me just demonstrate. I could do that if I ran a bash shell against one of the servers, and then they're running on port 1235-API-users. And this is the data returned, just an array of data. But if we try and say curl localhost 1235-API-users here, we can see we cannot connect. But if we curl our Nginx server, then it forwards the request to these nodes. And so note that if you're not using Docker, like in this example, you can instead just create firewall rules to deny direct access to the API servers. But that's all I wanted to show you in this video. Just know that if you're setting up a load balancer and your API servers can still be contacted, this kind of defeats the point of using a load balancer. If you like content like this, check out my courses in the description. They're pretty awesome. Also, if you enjoyed this video, give it a thumbs up, subscribe. If not, just go about your day. Have a good one. But thank you for reaching this part of the video. Alrighty, take it easy.